Welcome everyone to the August edition of Space Data Hackers. We are really excited to do the program tonight for a couple of reasons, because we've got space apps coming, and we've got great speakers. A great speaker we're going to hear from Daniel Bailey, CTO and co-founder of Astraea, a company that is doing something that's really interesting, I think, to all of us, a startup looking to leverage AI and the power of space data to electrify industry and do great things on Earth. So I want to talk a little bit about the updates we have for space apps and space apps prep events, and then we'll get to Daniel. We'll do our show and tell as we usually do, and then we'll talk about the Space Apps challenges. They were released in summary form, I think the week before last. The full details will be coming out in a few weeks, and we can form into groups to discuss and brainstorm about challenges that are of interest for the hackathon or beyond the hackathon. So first and foremost, it's Space App season. There are 5 weeks to the hackathon. This is kind of what we've been waiting for all year. And it's the 10th anniversary of Space Apps, which is incredible. The theme is the power of 10. One of the cool things that they did to go with that theme was that NASA got 9 other space agencies involved. So there will be 10 space agencies with data brought to the hackathon for hackers to use and leverage in solving the problems that the challenges present. Registration, go to spaceappschallenge.org, and you can register there for the Seattle edition or for the Tacoma edition that Joe is running. In addition to the hackathon itself, we've got some pre-events. On Thursday, the 16th, we will be having a winning strategies for space apps, which is kind of an introduction for folks who haven't hacked at space apps before, to get familiar, understand what to expect going into the weekend, to have a chance to form teams, get to know people that could be on their team. On the 23rd, we'll have a bit of an intro to hacking with space data. For a lot of our experienced hackers, it's probably going to be something that they've heard before. But we want to be sure that folks are rolling into the hackathon with as much prep as possible. We're setting these events up to kind of plant seeds in folks' minds so they can go off and do self-study before they come in on Friday, which is a kickoff night. Saturday, all the hacking. And then Sunday is the presentations. And for our 2021 Seattle event, we've got a great panel of judges representing folks from Black Sky. Robert Kahn spoke with us a couple months back. Casey Dreyer, he's head of policy for the Planetary Society. Kind of cool having somebody whose boss is Bill Nye on the judging panel. Elizabeth Frank, she's a senior planetary society, senior planetary scientist at First Mode. Ray Ramadorai, who's a principal technologist for avionics at Blue Origin, and So-Yeon Yi, Korea's first astronaut. They will be our panel. So I'm going to pause before I go rattling off too much further. Any questions on space apps? All right. I know that we've got folks who are old hands. And Daniel, where are you based out of? You're in Virginia, yes?
Yeah, I'm in Charlottesville, Virginia, so it's getting to be a bit late over here. Long day,
Oh,
but appreciate the invite to join, and really looking forward to telling you a bit more about Astraea and learning a bit more about what you all do as a meetup and the Space Apps Challenge you guys work on, and the show and tell part, which sounds really interesting. So thanks for having me.
Yeah, no problem. So, like I said, Daniel is co-founder and CTO of Astraea. Served in as director of commercial analytics at Elder Research, a machine learning and data science consultancy, decorated war veteran, with a specialization in signal intelligence. I've probably got some questions a little bit later on about that, how that plays in. And your degrees are from North Carolina State University in Applied Mathematics and Advanced Analytics. So welcome.
Thanks.
Yeah.
Yeah, I have, I think just to check on Tom, I have about, was it 20, is it 30 minutes total, or what do you want me to keep this to? Because I can jump around and shorten or lengthen it depending on what you're looking for. I wasn't sure. I think I saw 30 minutes, but I want to make sure we have time for interaction and Q&A and any of that kind of stuff.
30 minutes sounds great. We appreciate you staying up with us. And some Q&A is definitely going to be a lot of fun, I think.
Yeah. So I guess I'll start off where I'll share the screen. I got a few slides to go through. We have a pretty big platform that we've built, and so it'll be a bit of a whirlwind, but we can slow down, and I'm going to try to keep it to about 20 minutes to tell you a little bit about what we do, show you a quick demo of the platform, and talk about ways that you can engage with it. We have a number of different products that we've developed and support, ranging from open source distributed computing projects like raster frames, which is bringing geospatial and imagery data support to the Spark ecosystem, all the way to some of our other proprietary solutions for monitoring and other things. So I'll share my screen real quick here and kind of jump in and tell you, I appreciate the kind introduction there, Michael. I'm happy to answer more questions about myself, but I would actually like to learn more about you all and where you hail from. And we have a small enough group that we can have some interaction there. You can raise hands or just indicate. Is there a number of Earth observation or remote sensing or image scientists in the group, or are we more space data?
Well,
so
I'm the one that wrote the obnoxious email to your company.
It was, I don't know, I would say it's obnoxious. It was very well thought out and formulated. So it was very interesting. So I think you've been doing this for a while. You're an old hand at it. Others experience with Earth observation data or looking to leverage it? So not a lot here. So just more interested. I'm trying to gauge on how deep to go and what to talk about a little bit there. So
well, I think we're all nerds of one flavor or another.
Sure.
So I started this meetup, I guess this year, because we were looking as the organizers of Seattle's event for the NASA hackathon to have someplace where you can get together and talk about space data and doing things with it, and maybe do things with it. So we've run this for a few months now with a learn, connect, do paradigm. And some of us are experienced with data science, some of us with cloud computing, some with like Michael with the deep space data background. Right. It's a mixed bunch.
Cool.
And we're all here because we love space, we love data, and
My kind of people.
Right? That's the stuff.
So
Yeah,
what excited me about your offering is it's kind of ideal for this crowd, because
yeah,
you remove a lot of the initial barriers dealing with remote sensing, and then also the analytics that come afterwards. It's probably 100 times easier using a platform like yours than starting from scratch, going through a catalog and trying to find what you need and then get it into the right place. So thank you for coming tonight.
No, our pleasure. Our pleasure. I'm glad to hear that, and hopefully, I will, speak to all those different interests of data science and cloud compute and Earth observation and remote sensing as we talk about it. But Astraea, I understand what you're going through, because one of my other side jobs, I run our local data science, not EO specific. We do have a big EO theme to it, and here in Charlottesville, and so I run the meetups there for the Charlottesville data science meetups, and understand how that is to kind of wrangle speakers and do that. So it's our pleasure to help and kind of try to provide a view from the other side of the of United States. So at Astraea, we did exactly as Michael said. It was a great intro. I couldn't have said it better. When we started this 5 years ago, we kind of had the concept of like, oh, we had a NASA co-founder with me and a couple others, and I'm a data scientist by trade, and we have, one of my other co-founders is a senior software engineer, cloud computing, chief architect type, and is building the platform with me. And we ran into the same problems, exactly like Michael said. The data is like a death by a million portals. Data was all over the place. It was hard to get to. Trying to figure out what to download, and then you had to put it on a drive, or you had to figure out how to stand it up. And so we made a decision to try to create a commercially friendly, cost affordable platform for interacting with and leveraging Earth observation data to make better decisions about the planet we live on. And that's our mission, and that's what we've been working towards. See here, I'm going to stay out of presentation mode because I hate how PowerPoint takes over. So hopefully you can see the screen and let me know if it's okay. So we're a benefits corporation, which we are a for-profit, for-good company. So part of our charter is to we hold ourselves accountable to work on projects that help make a difference on the planet. And so we do a lot of work with conservation, sustainability. One of our largest clients is the Nature Conservancy. So we do a number of things across their chapters. We have a lot of presence in, I think it's the renewable energy already, sustainability, agriculture, things like that. So we're really trying to help organizations based on whatever, meet them at where they're at with whatever budget, to give them better situational awareness and help them extract information out of Earth observing data. Kind of already covered a lot of the vertical focuses that we have there. I'm going to try to go fast through the slides, so slow me down. This is stuff that I don't probably need to tell this crowd, but we're facing a lot of challenges. Climate change, global supply chain. A boat can turn sideways in a canal and shut down our global supply chain for weeks on end, and people get upset because their Amazon purchases don't end up at their front door on time, and all that kind of stuff. We do see a lot of, and what we're excited to see in the ESG space is a lot of work to decarbonize the planet and to move to smarter uses and no-till agriculture, renewable energy, to help decarbonize and other things. And then with ESG, having corporates and governments understand that it's, we don't have, the environment and water and all that is actually a input cost that you should have. It's the true cost of manufacturing, and it's not a free non-ending source of your supply chain that you can just kind of take advantage of, because as our watersheds and streams and other things break down. So we see all these problems, and we're just a small company, but we like to say we're the lean mean fighting machine, and we work really hard to enable people to make better better decisions and do our part to try to solve that. We know we don't look at this as a zero-sum game. There's other folks out there doing interesting things, and so we're pretty open. We contribute to open source as well as having our proprietary option. Everything we have is there because, you know, the challenges are big enough, you know, and it's going to take all of us to understand the type of work that we're doing. So the great thing is, and from our perspective, is it's never been more exciting. From a data scientist, it's never been more exciting. We have more data than we know what to do with. It's just incredible. Every time I turn around, there's a new, and I'm in this industry, like actually monitoring. There's a new Earth observation satellite company, you know, planning to launch next year and just got funded, and the amount of money going this is insane. And it's, you know, and that's exciting in one way, and another way it's daunting because our tooling to leverage that and the knowledge to leverage that isn't growing at the same rate the data creation's growing. And so what we're finding, you know, is that we got a long way to go to educate, provide educate, you know, get in the universities. We partner with some universities and make our platform available to them to help people, you know, start to see what the value to become a remote sensing scientist is and a data scientist and how to use this data to a lot of these challenges. So, you know, we do fancy ourselves as a geospatial AI company. You know, as a data scientist, I will tell you AI I do not mean general AI. I'll just go ahead and put that out there now. Like, we're a long ways away from general AI. We do a lot of computer vision and automation of tasks and feature extraction that to a lot of folks feels like it's voodoo magic and AI, but it's really, you know, the deep, you know, like deep learning paradigms and stuff like that is we're in a limited AI task. There are certain tasks that we feel that we can automate for monitoring for certain change events or other phenomenologies from imagery that help people make decisions. So we're not suggesting that we have you know, we're not IBM who like to talk about Watson forever. That was going to do everything from an iPad. So I think that probably is understood in this group. But it does take different than like mainstream work that's being done in the ML, AI, computer vision space for like ImageNet and computer, because the type of data that we're dealing with is dramatically different than pictures of cats from the internet. You know, the bit depth, the channels, the you know, different bands in the passive optical. Then you go into the active stuff and point clouds and how you fuse all that together. It's a different world, and so a lot of even the architectures, and we'll talk about some, is found in the work there. A lot of the deep learning architectures and the AI research, and we've independently verified ourselves, and then research we've done, transfer learning from ImageNet in most cases doesn't improve your AI model. It actually will hurt your AI model for trading because it's optimized to 3 bands, red, green, blue. And if you're in a space where you're doing a multispectral with Sentinel, where you're passing 9 bands or 12 bands or whatever you want, it's actually has to forget what it learned and relearn it. And so your training time is greater than if you were to start from a bare bones, unoptimized, you know, unseeded architecture. And so that's some of the work that we're doing to try to create better starting points of architectures, remove the complexity of the DevOps, and meet people where they're at, whether you're a GIS analyst, or you're a data scientist, remote sensing scientist, or decision maker, creating different abstraction layers of software so you can interact with this data and kind of meet you where you are to make better decisions. And that's all from a single platform. So we take a very you know, software engineering approach to this, where we've created a whole platform built into Kubernetes that's scalable, has different microservices to quickly kind of create a Gutenberg printing press of these type of applications so that we can quickly spit them out and meet people where they're at. So at the end of the day, we used to see ourselves as, you know, a benefits corporation we're enterprise geo AI for a changing world. So we're really focused on trying to help commercialize this, supporting NGOs and for-profit companies to access this data and make better decisions about their operations. So where that kind of breaks down into is we've been working to create an integrated GeoAI ops platform that goes from all the way from the data all the way to the delivery. And so we have on the left-hand side here, we have our Earth AI data. It's a virtual constellation. Black Sky is one of our partners, Maxar. We also have beyond image, we have a lot of the data sources from the public available, NASA, ESA, others, Capella, and the synthetic Aperture radar is a partner. And then beyond that, we also have Cubic, which is location data. So we have some other geospatial data there to understand location data from cell phones. And we make that data available and help simplify the procurement of that data for our customers and partners, making it super easy. And then when we do that, we also then don't just like send them a link to an FTP download site for them to go get that data and have to do it. We actually will pull that data in and put it in our Earth on Demand catalog, our Earth on Demand application and a private catalog for them. That it's side by side, and I'll show how this works with a lot of the other public available sources, Sentinel, Landsat, NAPE, other things. So you can kind of have that data next to other data that is available, and you can search it over space and time and figure that out. And then that our Earth on Demand is really kind of I often think about it as a bit of a central nervous system for our whole platform, because it's based on a GeoAI data model on the back end. And so as you have a model result that's derived from the image, or a labeling training program that was used a bunch of different images, we actually associate in the metadata model behind it that there's this label or a model result tied from which the image it was derived from, so that you start to create this repository as you're using it of a training data set, model result set that is searchable, discoverable, and extensible across your organization. That system, Earth on Demand, also has integrations into QGIS, ArcGIS, and then also into our notebook tool. It does provide an API on the back end for machine-to-machine access, so you can make calls to it without actually using the UI to power your own apps as well. And we'll talk a little bit more about that. For those that are familiar with coding and want to like roll up their sleeves and build some of these deep learning architectures, we have Earth AI Notebook, which is a customized Jupyter lab environment. It has Python support, R support in a beta version right now. We just brought in some R, and interops with Google Earth Engine, so you can make calls to it if you're using that. We interop with a number of other systems. It comes preloaded with all of the kind of mainstream geospatial Python libraries, and takes care of all the DevOps for you. And so we do a lot of the Python. We kind of take care of the Python dependency hell you may find yourself in sometimes. So trying to figure out whether you want to get TensorFlow or PyTorch. We have TensorFlow, PyTorch, FastAI, all that's installed. Rasterio, GDAL, everything's there, Spark enabled with our raster frames, and all the dependencies and things are sorted out. So you can just get in, use the data, and start answering your questions without having to do a lot of work. Our Earth AI Monitor we're pre-release. That'll be releasing here in the next month, and I'll demo it in a alpha version right now. But this is kind of going the next space where this isn't where you're building your model. This is where this is more of an operational tool. We're using it within the renewable energy to help renewable energy developers monitor the progress of the construction for different policy, state agencies like Virginia Department of Environmental Quality, make sure that the development is being done according to plans, and they're getting automated alerts when something changes or when panels are in and how close they're done. We're also building a similar capability for ecological condition monitoring with TNC to understand the health of longleaf pine forest across Southeast United States, and the value, the measuring their impact that they're having on their conservation programs. And then in the far right, we take this kind of powered at the bottom, you see by Earth AI Pulse, which is our ability we've created this robust GeoAI infrastructure that if a customer has a need that we to have a custom tool, or maybe they have a custom algorithm, we can actually deploy that for them, and then make the API available and build custom front ends, which we do for a couple of our clients. And then we handle the a lot of the automation and making them smarter, essentially by leveraging our infrastructure that we built. So I'll pause there. That was a whole big, I did promise that it's a pretty extensive platform, so it's a lot to digest and go through. I can the next step here would be to, I think, let's see your next slide. Well, as I was saying, so like I said with our Pulse, you know, we're up here on the left is a renewable energy company called Black Bear. They do rooftop commercials. So we have a custom app that we built for them that automatically, you know, detects what's on the rooftop, whether, you know, where the solar's there, and allows them to do different configurations on that takeoffs, to give clients that are interested in installing, you know, going green on their buildings, commercial clients going green, and having a local install. The bottom was the ecological condition monitoring that I was referring to. Up in the right is a early pilot project with SAP around farming, and then the bottom, which I'll demo as part of the overall demo, is our Earth AI monitoring app. All this is powered by the same platform and is enabled by our kind of Pulse technology to built on Kubernetes to automate these pipelines, have Argo workflows and other things behind it. So I'm dropping some terms in there that may not mean something to everybody, but if you're a data scientist, it may not mean a lot to you. If you're a cloud computer and engineer, you probably understand what those technologies are and why they're important. But we're happy to answer any questions. So I'll pause there. The next step is to go to a demo. But before I get to the demo, is there any questions out of this massive kind of, like, I feel like the old Micro Machine guy. I don't know how many people remember him that talked at 1,000,000 miles an hour.
So one of the, for instance, there is an interest in this group to build a basically around wildfires, right? And so part of that is, you know, what data, the initial question, what data do you have available, right? You have Landsat,
Right.
MODIS, and, you know, so that's probably already presenting itself as an issue, you know, what platforms out there and what do they do? And then the MODIS and Landsat collections, obviously clouds, other, you know, terrain correction, you know, all of the other stuff comes into play. And so one is starting from scratch. One could spend the better part of a couple of years, you know, just developing basically a graduate degree in remote sensing so that you can begin the problem. And this tool chain here enables you to get right to the meat of the matter, so to speak, and the skill set that you specialize in, right? Not having to, and then what is also a barrier for most people that come from a data science world, or they think they know, I'm sorry, they think they know what big data is, but sorry, I'm so, you know, cynical about that. But when you start having to pull around gigabyte, you know, for a single image, all of a sudden the plumbing is a huge issue, and may stop you dead in your tracks, because now you have to set up a way to tap into just the parts of the image that you want, which is an entirely other skill set. So I'm excited about this. This is cool.
Yeah, we do that. We built our system kind of from the ground up, assuming a cloud native environment. You know, you kind of hit on when you talk about imagery data, the file formats and the way is optimized for storage, not for analytics. You know, and so they often are very large. There is a lot of great movement in collaboration around, I will say, NASA and USGS and Planet, Maxar, and we've been in there for a long time around things like the Spatial Temporal Asset Catalog, which is specification to be able to understand and discover different repositories of data and index them quicker. That paired with the cloud optimized geotiff format, COG format, allows us to do range reads and other things to get to just the parts of the data we want, not the whole
That's so huge.
scene or download. And then when we combine that with what we have in our Earth AI platform with the serverless compute engine, that we can actually do a lot of different transformations on the fly and different map algebras and do cloud and shadow detections and other things and the serverless, is that you actually then can get a rendered analytic on the other side without doing much of anything other than requesting that it be done from the computer. Yeah, so let me get out of this. I'm gonna stop sharing if that's okay, and try to time check. Michael Doyle, can you keep me honest and let me know where we're at with the time? So jumping in, this is just a quick little app. This is one of the solar apps. So this is really just a roll up. We do a lot of fusion of the data. Some of this data is coming from government sources. Other of it's coming from places like PJM, which is a control. So a control service organization that helps manage grids across different areas. There's about 9 of these control zone areas, if you were to look at it from this area. So PJM's here, and so this is a tracker to see which of these different states and how they're doing on installation of renewable energy and decarbonizing of their assets, and seeing how that kind of rolls up, and you can kind of see the power plants and states. We then, being from Virginia, are starting to track more things like Virginia just recently released a bunch of legislature to do it from the governor to set some pretty aggressive RPS goals for the installation of renewable energy assets across Virginia. And so what you see there, which is kind of an interesting thing, is that the yellow here is permitted versus operational. There's a massive increase in what's permitted, and all the ones that actually are permitted outpace any of the ones that are actually in operation today for renewable energy assets. One of the fun things I always love about GIS and GeoAI and things we do is, one of the things that caught me off guard is that there's a big density of these going in Southern Virginia. If you don't know your geography, DC's up here, Norfolk's over here, the Richmond's kind of in here. The largest power consumption is over here, and all the production is down here. Well, it's because land's cheap down there, and it's mostly farmland and agriculture. And so this is an interesting finding, and you don't see a lot of it over here. This is Appalachians. And that part of that is that Dominion was written into the legislation. They're the ones that are doing a lot of this permitting. APCO is another American Electric Power. APCO is what we call it around here. Oops, kind of fast on the trigger. Is the other publicly traded. And so both of those are written into the legislation. So from this, we can actually track to see how well they're tracking against our legislation as we're monitoring. What we get with that, though, is all this information is derived using up data, but when those things are, we can actually track. Gotta move Zoom. Zoom always gets in the way. Okay, Zoom, let me move your bar because I can't get you to go. Let's see here. And so what we get here is what we're providing for this is, here are all the permitted sites across Virginia, and we're monitoring them using Sentinel data. We've brought in the information, and we're looking for when different things have changed, applying change detection algorithms. And we have a solar model that's based on 9 bands of Sentinel that can, from coarse resolution, can detect when panels are coming in. Okay, that's interesting. I have not seen my error. Of course, it's a live demo, so those things always tend to happen. Let's see if this will work there. Okay.
Great way to QA.
Yeah. Let's see if it's apparently. Let's see here. Go back. See if all my imagery is not coming through. I did warn that this is pre-release. I am in a test environment, so I will have to see if my my developers have broken stuff. I did warn them, Shannon, didn't I? Yeah,
Continue.
so here, that's what we do. So, you know, what you're getting here is this is a solar site. We're monitoring it for change. You know, what we're getting is with these little icons is that the site prep had started. So they started clearing land. As we roll that forward, we're seeing that our algorithm had detected the first panel being installed. Right now, the reason that imagery is we're actually not storing. So this is part of our serverless compute engine where we're reaching out, we're grabbing the data from the cloud and we're transforming it and rendering a natural color on the fly. And so the site prep is complete. You kind of can see in the course here as I zoom in, there's some panels up here. Doesn't really look like it, but this is an algorithm we verified that, and it's interesting, you know, since we are geeks here, is that, you know, a solar panel, it does better using something like Sentinel because the shortwave infrared is very important to it because it acts like a black body and it's more of an absorber than it is a reflector of it. And so it becomes a distinction against other vegetation. Then I can kind of show that. And so this is example, you know, we do this for a lot of different things. It's as simple as adding a project. You know, you can upload your sites. Not really sure why I got the error there, but you know, here's another, let's see if I can, let's go to find another interesting file real quick. So this is, yeah, this is some work we did to detect solar panels over China, and start to understand what the pace of play is in China. And you know, you can zoom in and click on one of these and get a sense of China doesn't make a lot of this data available. So when I click on one of these, it should be giving me, yeah, there it's rendering the data. It's grabbing the Sentinel data for this site. Let's see here, it should be grabbing it. It's interesting. I did get a prototype, so I'm not doing so great about that. Switch this one. Sometimes.
So when new imagery becomes available, the algorithm or the pipeline realizes that and then generates the appropriate envelope.
All these, yeah, exactly. And so when we're doing this one, we're pre-discerning the sites, and for every site, when a new image passes, we're cataloging that. We actually clip it, apply algorithm, do the update, and then alert the end user whether or not there's something that's changed, or it's solar panels. And so it kind of becomes a hands off. As I said, the imagery and we're having some trouble, so I'm gonna move to the next tool, which you would have seen, and I think you know, we'll come back to the early. This is our Earth on Demand. You can go right now to earthondemand.astraea.earth. It's a free sign up. You can do a lot of things without signing up, but it's a free sign up, free registration. It doesn't cost you anything. You get access to a lot of these imagery data sets, SpaceNet, Maxar Open Data, NAPE, Sentinel, Landsat, MODIS. You know, we have the full archive of Landsat on there, 5 and 8. I don't think we brought 7 in because of scanline corrector at this point. And then, you know, if you we have a B2C package where you can use it as your own, where we help get you high resolution imagery. For some of our commercial clients, we actually host a lot of their imagery and their private imagery on there in an enterprise version so that they can share that across the organization. We do that for TNC and some others. And so, you know, what you would have seen had we been working on us do a quick research. So this is all Elasticsearch database in the back end. It's all using serverless technology. So just from that, I can get this wide area of what it is from what's available in Sentinel-2. I turn this off, we see that there's some higher resolution things. And so this was one of that first site we were looking at. We're grabbing that, we're rendering that on the fly right now. This is a black sky image, one of our partners. And so we have built a tip and queue mechanism. So as our analytics are doing it, when we get to certain stages of development, we actually will reach out and automate the request for tasking. So for about $200, we can task a high resolution image from Black Sky that allows you to be smarter with your Earth observation budget of purchasing of imagery. So we leverage a lot of the free open source data to create a tipping mechanism. And then when we get to certain events or episodes, we can then automate the whole process to say, go task a satellite. Usually within 48 hours, often with 24 hours, we can get the image back from our partners at Black Sky or Satellogic for in the $200 to $300 range, have a high resolution, up-to-date tasked image of your site.
So if you were a small city or a county, and for about $2,000 a year, you could set up a pipeline with Black Sky, request the imagery, and do like building code zoning violations and things like that. And the revenue you would make from the permits and fines would be 10 times what it cost you to.
Absolutely.
Yeah, that's very slick. Yeah.
And so, we got a whole bunch in here in Earth on Demand. So this is, you can download this as a asset bundle. You can get the different layers, just the metadata. You can get the visual and download it for use for other things. You can, pull this into ArcGIS or QGIS tile layers and use it with any of those mapping tools. I'm going to turn back on Sentinel-2 real quick, and I'll turn this off so we can kind of look at some of the other fun things here. We'll get that image. Let's see here, zoom out a little bit so we can get a sense of it. I'm going to reduce the cloud cover. So this is, on the fly. I can do a cloud filter and only pull the images that meet my cloud criteria. You can see over time from 2018, you can get a sense over space and time. What is the density of the data over this region? I can, limit it if I want to do something like, I don't know, let's say I want to get a summer mosaic of this area. Then with this, it'll probably tell me it has to make some decisions for me, but we'll see. Yep, apply changes. That's actually not a limitation. It's a costing thing that I remove. And what's happening right now for all of these scenes, our system's going out. It's pulling all the pixels for this. And we're creating an on-the-fly mosaic and stitching all these scenes together over this geographical area. And this mosaic can then also be, like I said, it can be used here. It can be exported. You do see some data dropout because of cloud, but we can do different mosaicing strategies to see kind of like, depending on what it is, you may have different mosaicing strategy. We get some clouds. We can also do different visualization analytics. So if we want to see greenness, we could apply an NDVI, and all this is happening on the fly using our serverless compute engine. We're grabbing the pixels, we're reconducting the bands, and we're applying them in a large scale maps. And so these analytic layers can then be exported. We can take this and by we talked about is like you can then save it to a thing. We can go over to our Jupyter, our Astraea notebook environment, which I already had open. So I'm gonna go to this one real quick. And when I copy that clipboard, I paste that. And now I have an API version that has all of the data, the bounds of that, what's available. And if I run that, I have a Python object by which I can work with. If I query that EOD object, let's see here, you start to see all of the different IDs and bands and stuff that were used to make that mosaic, and that you can just pull in and read all the tile layers and geometries and execute. So and then
you just treat entire scenes as just another Python object, basically.
Yeah.
Awesome.
And mixing. And so we have this is a full-fledged. There's a lot of example notebooks, case studies we built. It was mentioned before, I think you said about wildfires. We do a lot with chipping. That's we have notebooks and helps to talk about how you can create training data. This one here. This is a fun fact about our name. This STEP database is a land use, land classification training data set. that has about 2,000 sites all over the world that are for, against the Anderson classification. So one of the fun facts about Astraea and our logo, the colors in the logo are mapped to the Anderson classification colors for land use land class. And the A and the E together is about machine learning, about how it's not always easy to distinguish and to separate things. And so the A and E are together. So even our logo is kind of derived from some of this nerdy land, nerdy Earth observation stuff that we wear proudly. But this is the chipping's a really big thing, because we have different chipping strategies. And if you're in deep learning, it basically allows you to create training data sets, and then you can do different data augmentations. We run into this a lot when we have smaller sites and we're trying to use Sentinel data and the pixels are so big, trying to make sure that you aren't throwing away too much of your data and quickly changing the different image chip sizes, basically, and where you do scene align grid or other things. And this is a whole helper library we have in there to do chipping for deep learning applications.
You've optimized the size of that chip to the resolution and of the particular platform so that it has maximum utility for machine learning purposes. Is that correct?
We've given you all the tools to experiment with that. I wish it was that simple in some degree, but it's actually not that simple, because we've actually found that based on different architectures, there's different chip sizes and what you're trying to do, even based, so it's not just the sensor. But what we've done is we made it really easy for you to experiment across that and to make those changes with Earth observation data. We have a number of tutorials and other things in here, all the way down. This is one of the things where we're actually detecting site preparation. And so this is one of our one of the notebook on change detection. So there's a number of different notebooks. I did mention raster frames before. You can check that out at rasterframes.io. There's a bunch of examples. I'll just click on it from doing, this is a Spark environment, but if you're looking to do really large scale compute jobs, this is one way. We also, our system is also Dask enabled. So if you'd like to experiment with Dask and doing this from a Python environment, you could experiment with Dask. We have GPUs, we have PyTorch, TensorFlow, all those things installed. This in raster frames has it's written in Scala, has a Python API, but allows you to do map algebras and other things that are embarrassing parallel. And that those chipping strategies that I mentioned are in raster frames. So you can quickly kind of bring in and create different training data sets for things like wildfire and counterfactuals. We have notebooks to help you leverage things like OSM to do weakly supervised models. Kind of off on the reservation, but there's a lot there, and we're happy to anybody that's interested in trying it out. You can fill out a contact form, and what we do, we'll usually set up a one-on-one with our product manager, and they'll get you up to speed and then give you a 2-week trial to kick the tires and try it out. It'd be interesting. It sounds like we could talk about it, but if any of the group is looking to do some Earth observation for the space apps data hackathon, I'd be interested in seeing how we might be able to support you with that. Give you some access to the notebook and the tools to make it easier to get the data and to do things with it.
That sounds like a lot of fun. So
that's where people hit the wall. That's where people hit the wall.
Exactly.
Because they want to do imagery and they have an idea, etc. But if just getting started, almost makes it impossible for them to. But if they had something similar, like the tutorials or the template or whatever, that gets them a long way along.
Yeah.
Is this available at the starter price level?
It is. Yeah. Sorry, now everything's going, so it took a moment there. So you can also, if you want to take it out, you can go to docs.astraea.earth. You have a lot of different docs there for the notebooks, helper notebooks, Earth on Demand. how that interops, catalog, all that example workflows, and you can check that out on our Zendex documentation. But yes, it is available on the starter package. Shannon, you may have to help me remember, but our starter package, like I said, unlike some of our fellow competitors in the space, we have worked really hard to make this very affordable, because one of our big clientele are NGOs, and they have a lot of time and big mission, but usually are struggle for the funding. And so our starter packages are, I think we started about $100 a month for one. I don't remember actually. I guess I could go to the pricing page.
Yeah, I just put a link to the pricing page. I've been putting a bunch of links in the chat of all the stuff you've been talking about, and the pricing page I just put there. So yeah, you guys can follow those links if you want to.
Yeah, but yeah, for sure. And if you're signing up some teams, let us know, because it'd be interesting to see if, especially I was just checking out the space apps. There's some really interesting EO related opportunities on the challenges page for the space apps.
Absolutely. So, a lot of the challenges are Earth observation oriented and working with space data.
Well, in that case, and kind of building what Michael said earlier, how intuitive would this be for, say, a group of hackers who have 48 hours to tackle a program? Would they be able to really jump in here and get something going?
I would. Well, that's a bit of a loaded question, but assuming you worked with Python, I would say coding would be, if you're going to do something, there's an assumption there. If you're a hacker, then you have some coding background. If I assume that, then yes, I think you could be up and running pretty quickly. We can always assist with that.
Yeah, Nick, maybe this is a conversation we want to have offline with Daniel on how we, bring Astraea to the program. This could be really powerful.
Finishing up, kind of just moving, and this is my last slide, I swear. We also do a lot of different research, and we've done, as I teased earlier, we've been doing a lot in creating, looking at human machine teaming interfaces, human in the loop. We have integrations, which I didn't show, to training data platforms like Labelbox. We actually have some light labeling capabilities internally where we can run a model and then do QA, QC verification with distributed workforces. So we have distributed workforce partners to do some of that labeling. We are done some experimentation with self-supervised learning because, quite frankly, we'll never be able to create enough training data about the planet to create all the models we want to create about the planet and AI models. And so we're working to figure out how, ways that we can create weekly supervised models, leveraging things like OSM or enterprises vector data that they're creating operationally, and how we can then use it and be able to tie it to images of the same space and time to create training data. And then we do a lot of work, as I mentioned, raster frames on distributed computing frameworks to make it easier to process imagery. And then some research in multi-source data fusion. So the bottom right there is where we're using planet imagery as opposed to counting cars. We were actually creating an algorithm to estimate car density on parking surfaces. And so we could understand how full the cars were at theme parks and other things. And then we can fuse that with location data, because both of those data sources have biases. Location data is only a sampling of who happened to attend, show up that day. And car counting is an imagery, with even planet being great or symbol being good. It's only once a day, sometimes every day, if you don't get clouds in the way. So it has a higher, has a bit less bias, because you can see how many cars. That has an association how many people in the park that the location data has, but it doesn't have the temporal frequency that location data has. So we've been doing work to fuse those two together to understand how they can help each other and other sensor data. So this is some of the work we have going on in our labs. And that's it. well, maybe it wasn't the last slide. This is the last slide. I really appreciate y'all having me, and looking forward to seeing how we can support you with the hackathon coming up.
Totally, this is great. Any remaining questions for Daniel?
I have a lot, but they're all for my work. I'm a commercial solar developer, so you pointed out lots of things I was interested in. But maybe I can try and reach out some other time and have a proper conversation.
Yeah, shoot me an email, dbailey@astraea.io, and happy to jump on the phone and talk through, see how we can help you.
When you singled out Southern Virginia, you pointed straight at one of my projects. So
nice. So you're down there in Danville area, huh?
Well, we're all over the country. Yeah, but you were right. The land there is cheap, and on top of that, the local counties have very welcoming governments for solar projects.
Yeah. I'm actually, I just had a meeting right before this meeting. I'm on the planning commission for Albemarle County, for our local county, and we just approved 2 solar projects in the last month for our county as well.
Anyone
One
else?
of the other things that I like, so Google Earth Engine is JavaScript, and most of my experiences with Python, so it isn't going to replace Google Earth Engine, but it does give me another path.
You can put your tokens into Earth AI, and you can pull stuff over from Earth Engine, interoperability and all that. Yeah. So we take a very yes and. I mean, TNC uses Earth Engine a lot. There's people that use that. So you know, we're not a either or, we're a yes and company. You know, there's enough challenges out there for people to worry about it.
And maybe you mentioned this, but if I had, say, ArcGIS shapefile, could I import that in and interact with it as well?
Sure. Yeah, and the monitoring tool too. If you know, depending on where you are, you can just upload those shape files and create projects and start getting data feeds of the imagery as the project's unveiling, and then do tasking from it as well. Yeah.
Great.
Yeah.
Maybe I have just one other question. Whose cloud do you build on? We
primarily on AWS, but we're built on Kubernetes on AWS. So we've actually taken a lot of things. We do certain AWS services, but we could be multi-cloud. We just have stayed with AWS at this point, but we have supported other clouds, which is, you know, when we're calling out to GE, we're actually reaching over to Google Cloud to do that. AWS primarily, but all of our software build is using software packages like Kubernetes and other things, and containerization, so that it's not actually a single cloud tool. Gotcha. So that we can also do that allows us to do on-premise for some of our clients too, so we can move into their environment.
So are you doing anything with synthetic aperture radar?
Yeah, we do some, and you can actually, I should have, see if I can find my thing. If you, I'll promise I try not to be quick. I don't want to take over your whole thing, but you know, see if we were to change this up here, you can grab Sentinel-1 data.
Oh, there we go. For
this area. We'll go back to scene view since we get rid of that mosaic. And so, you know, let's clear our coordinates there. It's getting it. Let's go around here. This is always a fun one. I'm going to make it a little bit smaller just on the sake of time. Come in here, grab that. We have these different, let's change off Sentinel-2. Let's turn to Sentinel-1. It's going to show me that I can't do that. We'll do a default view. One of the things I actually like to do with this is to do the, let's see here, false color urban, and we'll click here and let's do a mosaic view and see what we get back. Should be rendering. Sorry, it's taking a little bit longer. It's all fun. So now we can zoom in and kind of it'll be rendering. We're grabbing this data and we're computing it so we can see different things within synthetic aperture radar. Get up into here, you can see some of the bridge and the boat traffic going across it using synthetic aperture radar.
So you could, if you have a large, one of the difficulties is mosaicing synthetic aperture radar scenes, and then always does your thing pop? In other words, what polarity, what polarization, combinations, and then even parts of a scene, from one side to the other. And this is very cool because it allows you to explore with those things very fast.
Yeah, very fast. And so this isn't just the VV polarization, and you get different things. And there's, this isn't meant to be, if you want to do deeper, you would go into notebooks. If you wanted to do denoising and other, using something like Sentinel-1 toolbox or something, Snap toolbox to do deeper image processing. But this tool, sorry, HV, sorry. I don't know why those aren't showing. This is using the different polarizations together and equivalent to an NDVI, so you can just see different things. I'm not really sure why it could be that I have a different mosaicing strategy. So anyways, but that's, we have some there that you can check out Sentinel-1. You can pull it over, you can do the same copy and paste, and now all the scenes are related to this are in that query within Notebook, so that you can do other image processing and different advanced things as you see fit for your analytic and algorithm you're trying to do.
Thank you very much.
Is there a support community, a forum?
Yeah, so our Sendesk Support Center is where that docs.astraea.earth. You can get on there and ask help, and there's a community page on that. There's also a submit a request and different things. If you ask a question there, we'll answer it for you.
Cool, thanks.
Well, this is fantastic. Thanks so much for burning the midnight oil on the East Coast to share this with us.
My pleasure.
If there's no other questions, I'm going to go back to my slides, flip it on. I think from the perspective of time, we might want to move a little quickly. I'll ask if there is anyone with a burning show and tell item, something that you've done or learned since last time, something that you're working on, if you're somebody new, something that you either have an idea that you'd like to express or something that you've been working on outside of the group that you'd like to share. This is your moment to let us know.
Well, I always do, but other people.
You always do. Any of our new joiners have a background in space data or a little side project that they're doing? Okay. Michael, is there something specific that you wanted to share?
I just have maybe 1 minute per slide. I have 3 things since the last thing, which are kind of general interest. I won't necessarily go into any detail unless there was questions. So,
well, go ahead. I'm going to stop sharing and I'll let you go for it.
Okay, let's see if I can. I participate a lot in LinkedIn, mostly because it keeps my skills up, and ran across this. Somebody had a proposal for floating solar panel arrays. Hey, you have all this ocean, why take up valuable farmland and et cetera, when there's all this ocean out there you can put your solar panels on. And they insisted that, well, you can just put them in sheltered places, right? And Seattle being a kind of an ocean city, we're probably more familiar here than a lot of other people in the world. And so the question I proposed to him, my claim was there are no sheltered ocean places. And so this showing there is my ocean, which is derived from the Copernicus program, ESA. And what they do is they've had 3 or 4 satellites participating. It shows you almost in real time what the sea state is in any given place. And then you can also window that over time. So you can interrogate a point on Earth and look back at what all sorts of things, the wave frequency, wave height, there's probably 50 different ways that you can look at it. And we're familiar with the problem because I also back that point up with that within an hour and a half of my front door, we have lost 2 major concrete structures, and one of those was in a lake, But this was, a quick use of space data, to maybe help somebody improve their idea or proposal. And the other fact was, so if you do have to do that, well, where would you put it? And so if you look at oil platforms, oil companies, man, don't spend any more money than you have to, is using the shadows in imagery. If you're looking at a particular place in the world, is the jack-up height of the exploration rigs and the permanent platforms are usually calculated above the maximum sea state that they're expected to encounter. And so using remote sensing, you can also, indirectly figure out the optimum. So the other one had to do with
but Michael, does that take rising sea levels into account?
What's that?
Does it take rising sea levels into account?
At what scale? I mean, the Bay of Fundy goes up and down like 29 feet twice a day. So and then if you look at, the various places in the world, just sea level, and then the variation in sea level that goes on, those effects at the daily, monthly, seasonal, and even decadal scale, usually the climate change difference isn't as evident as those local effects, not yet anyway. So did that answer the question?
Mostly I was being funny.
Oh, okay, well. So the other one was just using, somebody was using Arcgis spatial statistics algorithms. They have a whole slew of those. And this relates to when you're doing data science, is representation of your data. And basically they were trying to do a heat map, a hot spot, whatever, but their data was linear. It was along a highway, basically mile marker data. And a lot of times documentation is not going to tell you. A tool will usually always give you some result, but it does not necessarily have to make sense. And so I just basically had to step her through the idea of a one-dimensional, two-dimensional, but if you use weather data or other sorts of data, you can get into even further dimensions than that. So I personally hate heat maps. It's a campaign. And then last month I participated in the Aurora Borealis, the National Security Innovation Network. It's sponsored by the DoD, and the challenge they gave us was providing operational data to soldiers up in the Arctic. And so we came up with kind of a pipeline from, different data sources onto Azure, taking it through a 9 pipeline. And then the trick is, the only thing that works, it's the worst place in the world for radio frequency, because that pretty aurora borealis is every charged particle that's hitting the Earth's atmosphere gets sucked down into 100 miles away from Alaska. So radio communications is really, really difficult. So the only thing that works really well right now is the Iridium network. And so it's a question of taking petabytes, terabytes, gigabytes of remote sensing information, and then cramming that down so it fits in a 9K transmission over the Iridium network. And then, basically gives the guy who's walking across the ice, a sound cue about what dangers are in his environment. So that was a way to take, that was a challenge to take this vast, these incredibly massive data sets and reduce it down to not even visual, a sound in somebody's ear that tells them, what's ahead, what's around them, etc. Because in one of those blizzards, you're not going to take off your gloves to poke at an iPad and your hands are full, right? So that was way fun. My teammate Elbert is here. He was awesome. I had a great team. They put in and we ended up being one of the finalists out of, I think it was something like 65 teams, and our whole team was newbie, people really new to this stuff, and we were competing against companies and academics with PhDs, etc. So they really shined. They were just a pleasure to work with. So that's all I got. That's kind of some things I've been cooking on. Let's see, where's the stop share? There we go.
Cool. Anyone else? Okay. So it's time to talk about the challenges. So what I thought we could do, I could just read the website to you, or we could all read the website on our own, and then break out into rooms to talk about particular challenges that are of interest. I don't know, has anyone looked at the NASA challenges as yet?
Yes, I have.
Yeah, but you have.
And I'm doing poetry this time.
You're doing poetry. Okay. Well, so we can do it. There's a couple of ways. We could the way that I was thinking was we could post interesting challenges into the chat if we've got enough of them to break up into multiple rooms. We can talk about them there, or we could just talk about them in the group altogether.
So is there a link to the challenges in the chat?
Sorry. Yeah. Just a second. Yep. It's this one, 2021 Space Apps Challenge. Yes, thank you, Trent.
Oh, great, thank you.
Oops, let's go back. So yeah, take a little bit of time to read them. They usually are categorized. And in the past, what we've done is we kind of like review the categories. But one of the things that they've done this differently this year, it's 25 separate categories, which are, you can filter the list by the kind of challenge that you're most interested in. If it's science applications, risk, space travel, data organization, AI, ML, right? You can just click on those and see the ones that that fit your particular interest. There's lots of different things there. I will note, Daniel, to your comment about if you're at the hackathon, are you a hacker or programmer? Not necessarily. So there's challenges that they've designed to be suitable for non-technical folk as well. But what we see is that the best teams encompass some strong ability in data science, as well as storytelling and graphic design and user interface to make compelling stories about the challenge that they're trying to solve.
Ontologies and interactive network visualization, because data search has always, for decades, been a huge issue.
Yeah. Well, that actually sounds like something that Astraea is kind of addressing. But
yeah, I was
to
actually,
some extent.
yeah. And how I'd probably approach it was the same way we did for the National Geospatial Agency hackathon, is use Watson to scan, like use the Google API to scan Google Scholar for to pick out what platforms with various keywords, et cetera, because the easiest way for me to get to the relevant thing is to find somebody else that has done it similar someplace in the world, et cetera. And then that gives me all sorts of clues of where I might look, et cetera. So in short, that's kind of what I have in mind.
Yeah, this is kind of interesting because it reminds me of, I probably mentioned before, in the first Space Apps Hackathon that I went to in 2015, one of the global winners came out of that hackathon. It was in New York, and it was NY Space Tag, and it was basically applying machine learning to NASA data sets to find out what the metadata tags really should be, because they're largely assigned by humans, and as such, they're not always right. And that project, actually, I learned a few years later, was incorporated into the information technology platform that NASA runs internally.
Yeah, when I think of Amazon's retail recommender, right? Or, on eBay, even Amazon, where it tells you other people that looked at this also found this interesting, right? Because if you could bring it down to that level, especially for people new to it. And there's another part of that is that in the past year, I've been running into a lot, is the people seem to have difficulty wrapping their head around the temporal aspect of remote sensing, especially when you're doing time series and things. And especially if you're bridging, people are doing lots of climate change stuff, so they want to bridge, multiple decades of data, which, we're on like Landsat 8, right? Sentinel, like what is a how can you get to the most common data set for what you're interrogating? That is not easily done. I saw this awesome bar on on Dan's display at the bottom, showing, what the temporal coverage was. And so a way to, I think that's part of that ontology problem. But it won't be necessarily remote sensing. It'll be natural language processing, etc.
Yeah, it sounds too, the way it is, that it would be best served in a graphical database. It almost sounds like where you can establish relations and nodes and kind of break out, because you have different dimensions. If you're looking at, is it a derivative data set, is a raw data set from the sensor, what's being used in topic modeling.
So we'd probably use some sort of graph database for that. Does your company, Daniel, does your company have?
We don't do as much of the natural language. My old job I did, and I did have my before I started Astraea, I did do quite a bit, and we used some graphical databases for fraud detection and other things, and some of that for insurance companies, which is very useful for that. But at Astraea, we're not doing the closest thing we're doing. It's not in a graphical database. It's actually a relational database, but actually the OSM data model is closer to a graphical data model than it is.
Yes, it is.
And so it actually is in a relational database in a graphical data model format. And so that's the closest that we come to doing graphical data modeling right now. Because we've modeled our vector data store similar to OSM's data model.
Any other interesting challenges to anybody else on the call?
Yes, I looked at the Lunar Surface Operations real-time collaboration, and
Where do we have that?
it's under apps. If you click on the second checkbox down.
Aha.
And I did a little Googling and found out that Nokia is planning on putting a cell tower on the moon. I don't know that it would be called a cell tower, but something like that. And they're working on, the mechanical hardware part of actually doing the communications. But I think this challenge is more than that. I think that what they're looking at is, getting everybody linked together here and on the moon, and collaborating with the data as well.
Yeah.
Anyway, that's the one that we looked at here in Tacoma.
So really interesting one that, that points to something that Michael was talking about a few sessions ago with the topological data for Mars and how important it is to be able to provide line of sight between your points of communication. And I would expect that that's how data would start to play in. All of the challenges are meant to involve data in some way. And to be judged, you have to kind of point to what data did you use. These challenges, as we're looking at them now, are in summary form, where they're just kind of saying what the challenge is about. When the full details are released, they will also be pointing to specific data sets or websites or APIs that you can go check out and use.
Okay.
Yeah.
Just to be clear, these will be NASA specific data sets, because that's their motivation for have the space apps.
Well, it's all of the above. It's all 9 or 10. It's actually 10 space agencies that are involved. Last year, I think we had what, 4 or 5?
Pretty sure ESA and the Japanese Space Agency were in there.
Yeah, last year we had NASA, Canadian Space Agency, French Space Agency, ESA, and JAXA. So there was a total of 5. So they added 5 more, and I don't remember the other countries that they added. The UK, perhaps, but I'm sure that it's further into the website. But yeah, it's going to be more, and they'll have more detail for folks to latch onto.
So the lunar surface operations, that is also interesting to me. A while back, the NIST, and in cooperation with some other, the DoD did this Tech to Protect, and it was all about, for first responders, you have a whole bunch of random people show up at any given disaster emergency, and how to stitch their networks and get their data flowing between them. So that's an interesting problem.
So it seems like the communication from the moon back to Earth is pretty low bandwidth. It takes time, and as the moon orbits the Earth, the signal gets received by various antennas, and all of that is
not anymore, or near term. I don't know where they're at with it, but at the Ensign hackathon, I talked to a company, and they do laser direct communications between satellites, and I don't know specifically, but they're already talking about lunar operations. The irony being that, or you still have to deal with the latency. You can't beat the speed of light, but quantity of data is not a problem. You know, if you want to move gigabytes per second, there's nothing in the way once you're in orbit. Yeah.
So live video, for example, if you had turned a camera on and somebody said, hey, go look behind the hill over there, see what's behind that hill.
The particular challenge, it sounds odd that you would go to Earth orbit and back, or you might go to one of the Lagrange points. But the problem is the orbital characteristics of the moon, like when you're in orbit, you're not very far off the surface, right? So in an odd way, constellations are problematic, you know, like the Iridium constellation or the Starlink or whatever. There's some weirdness with that, which makes doing satellite bouncing, because the horizon is so close, the number of satellites that you need in any particular orbit just expands into this absurd number.
They'll also be moving pretty fast too.
Yeah.
Although, I mean, the Earth is going to be in the same spot in the sky all the time. You know, if you're at a fixed location. So maybe building like a large tower or array is the best way to do it.
Any other folks have any particular challenges that stand out to them?
Or I'll just show up and randomly pick something.
Just fill in. The light curves on the asteroids is personally interesting to me because I did light curve analysis for my dissertation. So, but that's, and I got a soft spot for asteroids too.
I wonder if asteroids have a soft spot for you.
So I was curious.
I've heard that they're kind of fluffy.
About that asteroid thing. So since Arecibo went down, we no longer have long range, radar imagery for looking at those objects. But I've been doing, helping a guy with an SBIR with LiDAR, and just seems to me, you know, it's not like readily this minute sort of technology, but using flash radar or flash LiDAR, it doesn't put out an individual little point. Is what it does is it puts out a full field of laser light, you know, over say like 10 degrees by 10 degrees, and then the receiver it's like a video camera. It's like a LiDAR video camera, and it looked pretty exciting in terms of what you could, the possibilities of that. And if you could, it just seems to me physics wise, you could narrow down that beam quite a bit, almost as much as you wanted to, and then you can make the receiver as large as you would want to either, and if it was in orbit especially. And so you could do some really rocking imagery of those smaller objects at great ranges. So that's in the create your own challenge category. That if
Design a
anybody
new
was
space telescope.
Always remember that the invent your own challenge category is not eligible for global judging, but it's fun. Daniel, Jason, or Cody, any challenges strike you as interesting, something you'd like to hack on, either at the hackathon or separately?
I'm actually a little out of my depth here. I'm just trying to take it all in while I listen. But yeah, it's pretty interesting. I have no idea where to start.
Okay. That's okay, because we've got a meetup coming on the 16th of September to help you get started.
We also
Daniel?
have the wiki too. There's some notes in the wiki that have links. The Space
That's
Data
right.
Hackers wiki.
If you go to spacedatahackers.com, you'll find the links to our wiki that has a whole bunch of resources to help you get started.
So I have to hop. I have an emergency, but Daniel, thank you for coming tonight, and thank you for the awesome presentation.
Yeah, thanks so much. And thank you, Michael, for making the connection of Daniel to our community. Daniel Blackburn, who just went off video. Was there a challenge? I feel like you were about to point out something you were leaning towards.
Only because you prompted me. I don't have anything I'm leaning toward. Like if I had to start today, I'd probably do the what on earth is synthetic aperture radar. I think it'd be kind of interesting to like try to make a little infographic video, but otherwise I don't know offhand exactly what I want to put my energy to. Once we have more details, maybe that'll help me to decide.
Yeah, it usually does. Daniel Bailey, which one would you pick? Do you have you been looking at these?
Well, given my bias for what I do, I would probably lean to something in I think the drones and satellites for urban development, I think is interesting. When you read the description of talking about, you know, there's the sustainable disaster risk resiliency, and then I think the inclusive urban plans is interesting. That's been a big thing to look at where infrastructure is built and how that relates to different disadvantaged populations. So that's interesting. And then that also, there's another part to that too, but you know, stuff we do with like renewable and greenfield and reclaim lands. So that'd be one thing that would speak out to me. We do support, it's a little bit, the marine debris is definitely interesting. I would, where I shy away from that is I'm also aware of how challenging doing Earth observation on oceans and trying to handle the turbidity and other things of the water is challenging. So that I would shy away from that one because that was a really hard challenge for a hackathon. But that's probably where I would go into. Yeah, probably lean towards the drones and satellite urban development. The other one, I guess, is interesting also is the measuring the value of Earth observations. That's another one that's interesting to me as well. So.
Cool. Well, okay, I think we are starting to come to the end of our time. So I will just share my screen one last time to post what's up next. Just as a reminder, Thursday the 16th, winning strategies for space apps. Thursday the 23rd, hacking with space data. And Friday the 1st of October, space apps, Seattle kicks off. The official hackathon starts on the 2nd, like it runs Saturday to Sunday. But we do a kickoff night for folks to get oriented. We'll have a speaker and team formation exercises. So be sure to register, spread the word. I want lots of folks and everybody who's attended this meetup to join us at Space Apps and the events that we've got in the lead up.
Thank you, Michael.
All right. Thank you, everyone. Thank you, Daniel, so much.
All right, thanks, guys.
And let's talk about what we can do at the hackathon itself.
Sounds good. Thank you, guys. Have a good night.
All right. Bye.
Good night.
Bye. Thanks.